Alright, so let's do number 16. A landscape architect is planning to build an artificial waterfall in the city park. Water flowing at the rate at 70 meters per second will leave the end of a horizontal channel at the top of a vertical wall, 2.35 meters high. From there, the water falls into the pool. So that's pretty straightforward. Alright, so what's going on here? So you have a waterfall. So I'm just going to say in the city park, waterfront will leave or something gentle cell. So you're going to have water that's going to flow. Let's say that this is going to be some building of some sort. And this waterfall is going to, whatever this waterfall is, I don't know what I'm drawing, to be honest. But anyways, it's going to leave at some initial velocity at 1.70 meters per second. And it's, like you know, it's going to drop. And we already know what the motion is. So at the end of the horizontal channel to the top of the vertical wall is 2.5 meters high. So they don't give the distance between the, so here h is going to be 2.35 meters. Well, that's all they give. Okay, will the space behind the waterfall be wide enough for a pedestrian walkway? I don't know exactly what our length is. I know we're like, I don't know. If it's for over a meter length of x, then that's all it takes. So what we're going to do is we're going to find the time it takes for it to reach 0. And I'm going to call down positive in this case. Or maybe I won't. Actually, all right, so let's get started, folks. So I'm going to call that vector r. R is going to be the point x and y. And x here specifically is going to be 1.70, or in this case v naught, times the time it takes. So v naught is just 1.7 meters per second. Y is going to be some initial height plus or minus, in this case, since there's no component, it's just this equation right there. So let's find the time it takes for the y to reach 0. So that means that once you do that, t says 0 at the h on both sides, change the signs, multiply by 2 on both sides, divided by g, so that would be 2h divided by g, t squares that, so we're going to square root. There you go, beautiful, folks. That's the time it takes for the wall, for the height to be 2.35 meters, and the speed is 1.70 meters per second. So 2h divided by g would be the time it takes, which is going to be 0.69 seconds. So v times that. So that means that we're going to take 1.1. What did I put here? So this is going to be 1.70 meters per second times 0.69 seconds. So here the gap is going to be 1.17 meters. So that's going to be x here. 1.17 meters. That's what I just solved. So will the wall? So I don't know about you folks, but there's no way in hell we're that fat. So the answer is yes. So if there's a person there, that it definitely would be. It would definitely be past him. All right, so let's see what part B is. To sell her plan, the city, so I guess we're done. Council argues it wants to build a model to a standard scale 1/12 of the actual size. Ooh, how fast should the water flow in this channel? Oh my God. So let me define x as to be 1.17 meters, because that's what it is. And in order for this to be actual size, to be 1/12 of the whole model. That means that the height would have to be 1/12 of that, and that x would have to be 1/12 of that. So it's really going to be the same thing as this equation. Really, more than anything else, is, you know, x is just going to be b naught t, y is just going to be some initial height, which is the only difference is going to be 1/12 of that height. In fact, the whole thing is just going to be 12 of this, unless they don't take it into the account the. No, I think it makes sense. So, anyways, folks, in order to let's do the same thing, but instead of saying 2h over g, let's take this and divide that by 12. So now you're going to have 2h over g, which is 0.69. Actually, I'm not going to do that just yet. And they want this the velocity too, so we're going to multiply by x, which is going to be 1.17 meters divided by 12. And we're going to divide that by that time it takes. So it's actually, so we're going to take this and we're going to divide that by that. And I think that should get you the initial velocity of that. So let's check this. Actually, let's do this. All right, folks, I just fixed this up a bit because I don't know what the heck I'm even doing. So, all right, so take the whole v naught 1.7 divided by root 12, and that should get you the final velocity, or the velocity that this thing would have to travel in order for this bottle to be the same. So that velocity has to be 0.49 meters per second, I believe. All right, folks, enjoy.